on something there, so I forget. But where were you at, Beast? Were you on to?
Well, I was just okay. So we all know that there is an optical effect with long distance observations, right? Things will appear lower or higher depending on the temperature, pressure, humidity, etc. Right? And there's all different types of optical effects between you and the target, location. We all know that, and it's not consistent. And that's just because of air attenuation. Like there's a more shit between you and the target location to affect your observation. That's just that makes sense to me. Someone wanted to get in? I heard someone trying to get in.
Yeah, I'll make a comment about the what I was trying to say earlier about the celestial theodolite. That's what I was asking. If they're saying that there's some standard refraction happen because actually when the star's like right overhead, there's little refraction. More happens. So I'm like, are they saying this jumping? It's not like it's just crazy.
There's no like they can't say refraction because it's about the timing of the star getting occluded by the mountain peak. Like that's it. You have to have the same timing and show that it matches the globe, which literally no one has done. There has been no rebuttal like that. All they can say is, well, the measurement's incorrect or I don't understand it.
Yeah, they're saying that's an apparent star. Crazy.
Yeah, Taylor, that actually, so you broke up a little bit, but I think I actually made sense of what you said, and but you did break up a little with your connection. But yeah, that actually plays into one of the rebuttals I have for the Selenelian eclipse explanation for the globe is that they need it to shift in the sky, and if it shifts in the sky, it has to like jump forward and then jump back if it's changing. Otherwise, it's moving in its rate and its cycle in time, and you can't fool time. I mean, if it's every 24 hours, it's every 24 hours. So you can't change what time is or warp time.
The timing is consistent.
Right.
That's
exactly.
why it's such a good experiment.
Meaning,
and anyone can recreate it.
If you took a shot of a star, this is how you could verify this. Take a shot of a star when it's directly above you, and then and then you take a shot of that, where there would be very little refraction. It would be the claim, as it were. So that would be the and then as it gets all the way down to the horizon, you can time it to when it sets, and then if you know what degree of arc that all is, you can then calculate how if it did change within time at all, because it's either going to fit in every part or it's going to have to like Taylor I think was saying, have to jump ahead in order to actually be out of position or be in a fake position or be a fake star. It would have to actually do that. So yeah, you could just test it by doing the star when it's right above with no refraction, and then at the horizon, and then do the timing. And if it's close or very, very, very close, then there's minimal to no refraction, depending on those conditions.
Think about it, Gio. It's been 4 weeks, I think a little longer, since the celestial theodolite concept has been introduced. And have you heard any possible good rebuttal, at all?
No, I've only seen from the others, from that kind of side, as it were, the ones that are trying to actually, because it's one thing to put something forward, but it's another thing to attract all these people wanting to rebut it. No, it seems like it's kind of a lot of number fumbling, I would say, on their side. So it's kind of fumbling through numbers, but not really having an actual rebuttal for it. That's kind of a very simple, kind of crass way to put it, but it kind of, if I had to put it into one phrase. So no, but I wouldn't say any of those are I haven't seen an actual valid rebuttal other than basically trying to fudge different numbers, it seems like, versus them actually having any actual real world observations or data to even compare, to even have a rebuttal.
Haven't they been using refraction as a problem for occlusion with the sunset? Like, I don't think them saying refraction is anything new.
Yeah, but do you agree with the time thing that these things are moving in time? So you can't just like think about like all the if you have a 24-hour or I mean a 12-hour clock, you know how it's like 60 minutes, so it's like the minute hand. Like you know how every minute is like every minute is allotted its own space and its own time. 60 going all the way around, you know, or 12 for the hour hand, etc. So you can't like change that order. But if there is something that was refracted, it would have to jump ahead and then fall back behind in order to go out of that time sync of those actual slots.
Which is impossible.
That's yeah, so that's really pretty key. Well, that's why the timing is so awesome with this. Sorry guys, I have kind of a cough, so yeah, if I'm kind of like I'm just trying not to cough on the mic, but I do have a little bit of a cough, so yeah.
Do it.
Yeah, dude, I don't think I actually think what I got is actually I haven't been sick in a very long time, but on occasions I do get things. I haven't been sick in a long time, but I think this might be bronchitis because yeah, I had kind of a little mild thing like I wasn't even really sick, but then now like I've had kind of like a little bit of a lingering cough thing, so I just kind of, in a way, I self-diagnosed it, but I also kind of just got the insight that that's what it was. It's not, I don't think it's like a severe case really. And I can't think of any other time I've actually had bronchitis. So I think this is a first. And I kind of feel like with diseases, if you've never had them, like I think maybe we just need to get them once. And then my thought is build immunity and then never get sick with that again. And it's worked so far. Like I've never gotten sick twice from anything, only once. So if I've never had bronchitis, I guess I think I might have a little case of it. So yeah. Anyways, that's why I'm like I might sound like I'm coughing in the middle of talking, but it is kind of irritating. But yeah.
Do you work out, Gio?
But yeah. Yeah. I mean, I do exercise stuff. Yeah. I mean, I don't like work. I don't like lift weights per se, in that way. But yeah. I mean, I move my body. Is that what you mean?
Yeah. Yeah. You should work out every day. Get to the gym. Get to the sauna. I'm telling you, man. Super big difference.
Supposedly, even jumping, like using a trampoline, is really good for the system.
Yeah. I mean, maybe not when I have bronchitis, but maybe some, yeah, at the moment, I'm probably taking it easy a little bit. Yeah. So.
You'll be back to 100% before you know it.
I know what I got it from too. So yeah. I got the insight as to what it came from. I get
What's
this
her
like
name? It's from like a
no,
bronchius.
it was from this raw sheep milk butter, raw sheep milk butter that I got from the Amish, and it's awesome because it's 100% grass fed, which is like almost like none of the companies are like doing that. It's like especially sheep milk, 100% grass fed sheep milk, and which is like almost impossible to get. But other than the Amish who actually do it, because all the like American people, they're all feeding corn and soy and wheat and GMO alfalfa and all kinds of stuff that it's like pretty much just doesn't even exist. But the Amish are still doing the grass fed like that. Anyways, but yeah, I'm quite sure I got it from that actual butter, not because it was in the animal, but I think just in like the handling process because yeah, they're probably just not like very sanitary. And I should have known that because like getting the milk is one thing because they put it right into glass jars and glass bottles, so that's one thing. It's pretty like clean, like it's coming straight from the animal, and I've never gotten sick from that. But I have like noticed, yeah, sometimes when they do like the creams and stuff or butters, because they're not cleaning their equipment, probably like ideally, like you pretty much need to be like medical level sanitary to really do that right, to like do butter and actually have it be not contaminated with anything.
What if it's triggering a detox, Gio? What if the enzymes in the cheese and all that jazz is just causing a detox? Not down for it? Okay.
Well, I mean, there's detoxification processes that do happen, but I've only had in my life like a small handful of like these kind of Like I had like a pneumonia once. I had influenza once. What else? I think, anyways, I've had a few, but no, dude, I think these are just completely like they are bizarre things. I think they're actually like of interdimensional origin. Like they weren't even made here. But yeah, anyways, but yeah, what they do to the body
just
is
a wink and a nudge, man. But cool. Sorry to interrupt your story.
Well, where were we at? We kind of went on a whole side thing there, but where were we at in the actual combo?
You were explaining you and Beasticles were going back and forth with the celestial theodolite, and I kind of thought it was interesting. You got a sort of slightly different way of wording the interpretation. And I wouldn't be like, if you wouldn't mind, sorry to make you talk again, but what was your way of sort of like breaking it down? Because I have been seeking for like different other ways that people are looking at this, and just like how they verbalize it and how they explain it, and I don't know. I think it's kind of cool to get everyone's different sort of angles on it. Pun intended.
On which topic?
Celestial theodolite. You sort of had like I don't know. You're sort of the way that you were thinking about it, the way you were wording it. I don't know if you can recollect necessarily, like what it's pointing at, what it's suggesting, what it's revealing. I suppose you might say as well.
Yeah. So, well, you're asking me. Are you asking me that?
Well, yeah. You. I thought you had an
So I think
interesting way
maybe
of go for it.
Well, I think maybe the point you might be referring to that I was bringing, and yeah, I could repeat that because I did kind of say it quickly, and it would basically be this. So if you are timing the occlusion of the star when it occludes to the mountain, and then if you were to start the timer right then and then let it run all the way, and if you get right back and it's 23 hours and 56 minutes, and then there's the seconds as well. So if you get it right down that exact time, and then the next day, and then the next day, and then the next day, you now have a rhythm. So it can't be refracted out of that rhythm because that's sidereal time. So the fact that this is using time with the geometry, the fact that the time has to fit into the actual, cycle, like just like the little notches on a clock, 60 minutes going all the way around, you can't just skip one or just have it bend out of place. And if you do bend it out of place, if it's going in time of 1 hour, or the second hand, whatever it may be, if it is going, then it would have to speed up or slow down in its actual pacing to even go out of position. So yeah, so the fact that this is using timing with the sidereal timing, you can match those together, and you could then indicate that nothing is refracting out of position in the actual celestial sphere in terms of its full 360 degree, circuit, as it were, from start to finish. 23 hours 56 minutes in terms of the sidereal day. So that would then falsify that thing is in any way out of position. Then the exact way that it would be, timed and mapped in terms of the surface of the Earth.
Yeah, that's cool. I was actually thinking about that. What was it? You said that there's a 4-second difference. Is it like every night or every evening, if you went to go repeatedly measure, was there 4-second difference in day after day? Approximately. You don't have to commit to that hard number. It could be point something, something, something.
That's 4 minutes, no?
Oh, you
That's
say
just
4
short.
minutes, sorry. My bad.
Yeah.
Well, it's 23 hours 56 minutes. Yeah, so it's like 4 minutes. 23 hours 56 minutes. So it's just 4 minutes short of 24 hours, and then it's like 4 seconds. So it's like 23 hours 56 minutes and 4 seconds. So it's technically like 3 minutes and 54 seconds. So yeah, you can time that every day, and that's what I'm saying. If you're timing it at that rate, then yeah, nothing is warped or shifted out of position, which then means that is a straight shot to that star, which then means the geometry of when it occludes to the mountain is valid, and one is going to show true and one is going to show false in terms of those angles.
I know I pop in and out a lot. Could I just say something about the equation of time over something like the reference frame of sidereal time? Is that okay?
That is a good topic. Well, did anyone want to respond to any of those last points, and then we could maybe shift to that? Unless, if no one does, then yeah, we could shift to that because that's a slightly different. But yeah, that is an interesting component as well.
Well, yeah, but I think yes. You know, if we all go by a set rate, but the thing is, in another way, yes, with the celestial and all that. I've done a similar experiment, but basically, I'll put it to you short. If there's 4 parts to the year, okay, of different lengths, whatever, one part of the year, let's just make it into 3 months, just to make it easy. Now, in the first 3 months, time goes ahead by, let's say, 4 minutes, and then goes back to normal. Now, if it goes ahead like 1 second a day for more than half that period, then what I'm trying to say is over the 4 quarters, if they're not exactly the same and they don't exactly balance each other out, there could be a way that you're actually lengthening time. Does that make sense? Like, if you go forward 5 minutes, then you should go back 5 minutes for the same period of time. If you go forward 15 minutes, you should come back 15 minutes for the same period of time. And I think with the Northern Hemisphere, well, I haven't thought it through, but the point being is that if we think time is strictly 24 hours, I wonder if we were to actually put all the numbers down into an Excel spreadsheet and realize that the average over a year is not 24 hours and it's a bit more or a bit less. But that 24 hours could be
Yeah, there is that
different.
fluctuation as well. No, you're right. Throughout the year, yeah, the equation
Yeah.
of time. However,
So,
but that's kind of related over a longer period than what we were talking about. Like if we're talking day by day.
I know, but if you go day by day and you say, maybe let's just go 4 minutes over 3 months, that means that over 1.5 months, how would you get to 2 months? 2 minutes. That's 120. So over 1.5 months, 120 seconds type of thing. But yeah, it's kind of like if you add a second a day for 365 days, for example, in one way, then you've added 365 seconds. You know what I mean? So I think over a year you could actually get it so that it's not 365. It might depend on what day you start on. You know, like anyway, but it wasn't to change topics. It's just something I always thought was worth discussing because yeah, if you were to study it for a whole year and stuff like that, and it moved forward in the last few weeks, but you know, time, the difference to my clock compared to digital, you know what I mean? Like if digital is the equation of time, but our clock is our sidereal time, for example, then yeah. Anyway, sorry. Thank you.
Yeah, for sure, dude. No, the sun does have that phasing amongst the background stars, as it were. The sun's the equation of time and how that relates to the sidereal day. But yeah, so the thing with the celestial theodolite is just, yeah, the timing, which is kind of similar to, like I said, the argument about the Selenelian eclipse, because so if the globe, so that it's the same thing. So on the globe Earth, they say for the Selenelian that there has to be a refraction occurring to where the sun has to be like out of position. So if the sun is shifted out of its, so it's not in its real position, it's in this refracted position. Well, same thing with that. So like the sun and the moon, they move like in They move like in their so the sun and the moon, like they move in their exact degree of position within what we could refer to as the zodiac, which essentially is just the entire star field. I mean, they, in terms of breaking it up, but there's degrees. Like if you break them up into 12 sections, you have 30-degree sections. So you have 12 30-degree sections, which makes up your 360 degrees. So the sun and the moon are in the ephemeris and are observed and are reported at a particular degree at all times. And if it were ever to not be in that exact degree, again, it would have to like same argument for the Selenelian eclipse in this way. The moon would have to like speed up and slow down or show a change in time to get out of its actual rate that it's moving. So if it's going to be in some refracted, like, even if they want to say like, like half degree difference or whatever, so half degree, well, in order for it to get a half degree out of whack, if it's moving at its rate that we know it moves in the ephemeris at its exact rating, like degree, like you have the degree, the minute, and the second, so you have all of that. So yeah, so it would have to actually change in the ephemeris and show that refracted effect if that ever actually occurred, or that should be easily observed, that we should be able to track the moon and watch it actually moving out of its normal rate in order to get into that refracted position. So since that isn't observed, that shows that it's not in a refracted position and it's impossible on the globe.
And that it's just above the horizon. It's just above our
Yep.
heads.
That's it.
That's all it is. So simple.
They're just opposite, and you can see them both.
Yep. The sun never goes beneath your feet, nor does the moon, nor does any celestial body.
Yeah, no one's ever observed that. Of course, it's always been above them.
I think that's a big fundamental difference between flat Earth and globe. Is you guys think stars are beneath your feet right now? It's so weird.
I heard you can't see the sun or the stars in space.
Realm, real quick, Realm, just to what they just said. McToon does have a thing where the moon is below horizontal.
So yeah, things can appear below and above horizontal. That doesn't mean they're below your feet, though. That's
I'm
for
just
sure.
saying, you said it's never been observed, so.
Oh, that the moon. So you think because it's below your horizontal, therefore it means it's underneath your feet?
No, but that would be an observation of it below you.
I mean, yeah, if you think, yeah, I guess so. If you put together like the horizontal is where your feet are, yeah, I just don't see it
Are you
that way.
talking about the dip angle?
No, McToon was on a plane and he took a theodolite shot from an app on his phone of the moon below is horizontal.
What?
Yeah, you guys never seen that?
No, I'm saying what, that you're buying that just off the rip?
Yeah, right.
No, I'm not. No, hell no. I'm just saying Taurus said it was never observed.
Yeah,
Well,
if
it's
I,
like the
if
whole.
I aim my
That's like
phone beneath my feet with stellarium, it'll show a bunch of stars beneath my feet. It doesn't mean it's true.
yeah, that's the whole thing though. Like when they did the Black Swan, where was the horizon? No one took a theodolite measurement to the horizon. Do you think it was above horizontal or below?
I mean, that's a little different, but
It's a good point, though. I mean, I think that's what I heard Jesse bring up. It is a good point. But yeah, I guess it depends on how like you're viewing the horizontal when you look out that far. I've critiqued Jeremy many times on that when he says, well, you could find the horizon above horizontal or below horizontal. It's like, yeah, just it's not what they've sold us that it is. So I don't know what is going on with it.
But that's the observation, though. The observation is the horizon above horizontal, at horizontal, and below horizontal.
Yeah, I agree, but I just don't agree that the horizontal means that's where my feet is.
I agree. I obviously don't. I don't believe that either.
Yeah, I'd have to add, this is special pleading. Like, if you saw anything go behind a building, like, let's just say you saw the moon, and it was traveling downward and it went behind a building, you would say, well, it's behind the building. But for some reason, whenever you see it past the horizon, go down, uh, for some reason, you guys say, well, it's not below the horizon. That's special pleading. That's a
But
foul.
yeah, but that's reference frame dependent, isn't it? Right? I'll just use your guys' argument against you. If you put a guy above the building or on the top of that building, would he make that same claim? Same time, same observation. We're going to do it at the same exact time.
I don't understand your point.
Well, it's observer dependent. So yeah, I wouldn't make a claim like, "Oh, that the moon just went behind that building." Yeah, it did for me, but it didn't for the guy on top of the building. So I'm not
No,
going to just make a universal claim every single time something's obstructed by the horizon. It's because the Earth is curving. I mean, I would stay away from universal claims in general because the possibility that you have absolute truth goes against your worldview.
Well, can I jump in, Jeremy?
Hold
Dude,
on, it's because Thor is a solid
Jeremy,
system.
hold on, dude. Well, let me actually jump in. Okay, if you want to jump in too, I'm glad you're at your mic. Well, do you need to go quickly, or can I go first? Either way. All right.
No, go ahead. I just want to say Thor is a solipsist. Go ahead.
Got it.
Well, I was just gonna say, Jeremy. I mean, it would appear below because on a planar surface, and if you're above it, you have a dip angle. Essentially, that's why that's why I mentioned dip angle. I mean, if you're in an airplane, your dip angle has to do with 30,000 foot altitude, whereas normally your dip angle on like celestial navigation might be 100 feet up or whatever on the mast of the ship or whatever. So, but it's the same concept. So
Yeah, but with a dip angle, the horizon, you're actually above the horizon.
with wait, say that again. With the dip angle? Yeah, in a way, yeah. Well, kind of, you could say that, yeah.
When you do a dip
Yeah, you have to look down a
angle,
teeny bit at it because you're above it, yeah, over a planar surface, which is exactly what would be expected.
yeah, that's what I'm saying. You're actually above the horizon, so you got to take your dip angle to where or whatever. But
Yeah, so if your elevation is like 35,000 feet, then yeah, that's your elevation at that point. But there's a lot of factors that go on there because of like cloud cover, how far you can see, and how that's going to change. There's a lot of factors in terms of getting to high altitude like that come into play.
I would still say yes, but there has to be something else going on there.
Have you ever had times where there's a lot of cloud cover and you can't see very far, and the horizon, like out the airplane is like all the way at a certain area, and then all of a sudden, like the clouds clear, the position of what you thought the horizon was will actually change, and it's not because of any contours of the surface. It's just the meeting place of the ground and the sky is going to change depending on how far you can see. And you can even see it where you get 50-50, where there's cloud cover off to the left and no cloud cover to the right, or something like that. And you can see the contrast. One of them you'll see really far, kind of like the black swan thing. You'll see really far and the horizon's way back there. The other one you'll see very close and the horizon's more up close because it's just you don't see as far. So it has to meet where it meets. And the further you see, of course, that's going to be extended. And if you're at higher altitude as well, then yeah, all those geometries are going to be at play. That's why the thing, if you go to if the sun sets and then you go to the top of the Burj Khalifa and you can see a little bit of the sun again, that's why. It's that same effect. Over a planar surface. And I know why they would say it would happen on a globe too, but it doesn't match the globe geometry, but it does overlap a little bit. There's a Venn diagram in the middle where it would happen on a globe too. you'd be able to see the sunset a little further if you went up in altitude.
By the way, I think Dr. Mike is getting more peaks right now. So FYI.
Anyone else, or just that guy? Is that guy just the only person that we can have do this, or is anyone else going to step up to the plate and do it?
You want to buy me a P90, P900, or a telescope, bro? I'm unemployed right now.
We could put a GoFundMe together. I mean, there's got to be people though that have money in this too, that or already have a P900. Like,
Why
we
wouldn't
don't
you
have anyone in here with a P900.
Why wouldn't you just get if you're gonna get something, get a Theodolite? Like, how much is a Theodolite? This guy can't be that much. Jesse's got like 18,000 of them.
Theodolite's,
Wait, why get a Theodolite, Jeremy?
He just got you.
Because now you can observe it and measure the angle. Now you can get a measurement.
You're not measuring the angle. You're measuring the timing of when the star gets occluded by the mountain peak.
Yeah, but it's just more data, though. You just have more data. So you guys want to draw straight lines to stars, right?
A celestial theodolite, bro. It's huge.
It'd be a double theodolite, like double dare.
No, you don't understand the concept then, Jeremy.
Just to also, what's kind of interesting, just adding on this aspect of the conversation. What's it? Dr. Michael said that he's putting together like a breakdown of how these theodolites are basically causing like, I don't know, basically, do you remember how he termed it? Like, it's causing certain,
There's
like
a
the way that
scaling
these
error.
theodolites move. What's that?
There's a scaling error that's compounded with the farther you are away from your target or location. And he has the calculation in there in one of his PDFs. And lo and behold, it kind of matches Earth curve, like to the T.
So that's going to be really interesting.
There it is. Yeah, that's the observation of it's the actual, everything above the ground that's doing that, not the ground.
It's like they gave us a gadget called the Theodolite, right? And then they're not really, like, they're not tricking you. Like, it's the interpretation of how the Theodolite's working in relation to the relationship to the horizon. But then because you can use it at short distances so accurately, it's fine. It looks great. But then, like, at the point at which it makes the leap to the horizon specifically, so like the qualities of the light, they're using they're using its sort of proximity, like how you would use it in close terms. They're trying to apply that to the distance and then just saying it's all fine. Anyway, I just wanted to jump in to say that Dr. Michael's going to be coming out apparently with a pretty in-depth response, and it's covering all that.
Dude, why would you not just get a Theodolite, bro? Now you got more data.
Theodolite for what, Jeremy? Just so that I can have a Glober say, well, that's just because of refraction.
I don't know. You're getting an angle to the mountain and the star, right? I don't understand how this works. Maybe I don't know.
No, you don't.
Why
You don't
do you need the
understand. Here, I'll
angle?
explain it.
The visual field. Oh, sorry. Yeah, go ahead.
Let me explain it to Jeremy real quick. Jeremy, it's just a plain trigonometric.
Hold on, man. I got to get my good earbud for you in because you got some staticky and I got my bad earbud in. Hold on a second.
Jesus Christ.
All right, if you're saying it to Jeremy, then he has to fix his earbud. Well, then
All right,
just
I got
2
it.
seconds. Well, I was just going to, yeah, I mean.
All right, let me just explain it to Jeremy
Go
real
ahead,
quick. You take whatever peak that you're looking at, right? You have the distance, right? The rise over run. You calculate your angle, right? We're not measuring any angle. We're just calculating an angle using plain geometry. That's it. Then we're waiting for a star to get occluded by the mountain peak. That's it. You take that timing, you put it in stellarium, then you ask for the true geometrical position of that star by taking off atmospheric refraction, and lo and behold, it matches plane trig.
That's game over.
That's
For
it.
that argument, that is it. Like, there's no. I mean, if that can just be replicated multiple, then
37 times now.
They
at
would
least.
have to. Then the point is they have to claim refraction, so they have to add in a thing, right? Is one in terms of that. Like, if you're saying in terms of even if they are claiming that they have to add that in, and then secondly, or they'd have to say stellarium's wrong,
which I've heard. I've heard that a couple times. Well, how come you're using stellarium at the peak of the mountain and not at the observer location? Because that's not when we're supposed to use it. Sorry, what were you saying?
I was just going to jump in and say it's because they want you to press that refraction button. And then just in response also to Jeremy, I mean, if you've got we're creating a right angle triangle from the observer to the peak, the base of the peak, or the center middle of the peak. We know that distance. We know the height of the peak. We know it's a right angle triangle. Well, that's supposed to be what it is, right? You don't even need the angle. You don't need the theodolite, the angle of observation from the observer's position up to the point. Like, measuring that angle doesn't mean jack. Do you get where I'm coming from? Like, you
exactly.
What I think you're actually kind of doing is like creating an image at the distance, but I haven't got my head around this explanation yet. It's like you're taking a snapshot there and using the angle from it and then transposing it over. But
yeah, no, that's exactly what it is. The snapshot in time, right? And the snapshot is confirmed, right? It's confirmed by when the star gets occluded by the mountain peak, because it's a physical mountain peak blocking the light of the star. Doesn't matter what refraction or whatever the fuck in between you and the star and the mountain peak. You're just taking a snapshot of when it gets occluded. Bam! You take that same exact timing. You go into stellarium at the location of the mountain peak, and you do another elevation angle to the star, and you take off atmospheric refraction. Hey, guess what? Matches plane trig. Game over. GG.
And then to bring mine into it, the thing I said, if someone's going to claim that's a refracted position, then they have to show when that star moved out of its cyclical pattern to get into some different position. Right. Because the shit's all on a cycle.
Their evidence now.
It's on a cycle. Yeah.
We only have a
timing that. Yeah, they need to have a timing that matches Glob, a Glob prediction, because it's two different calculated predictions, right? Because with distance, the farther away you are from the mountain peak, the more the mountain peak is supposed to be tilting away from you, right? So it would be lower, which means the timing would be different. They have to show that timing matches the globe, but they can't. GG. Earth is flat. It's so solid, and I think the more people replicate it, the better. I'm going to replicate it eventually.
Well, you know, it would be... Yeah, it would just be awesome to, like, time it daily. Like, every day it obscures behind the mountain, occludes. Boom. Start a timer. And then the next day, when it happens again, click it again. You know what I mean? Do that like as many days in a row, you know, and that'd be awesome. But because that would then show that, like, yeah,
it would shift, right, a bit, because it shifts 6 months out of the year once. You know what I mean? You see one part of the sky, and then you see another part of the sky.
Well, but that's more related to
Hey,
the position of
question.
that's more position of where the sun is. I mean, you should get the 23 hours and 56 minutes and 4 seconds if you were to time it every day. And my point in that is that if you could do that, it means you're timing a sidereal day accurately, which means nothing is whacked out of position at each day, meaning the rhythmic, the star occludes behind the mountain today, the next day, the next day.
I
But
got you.
that would
Yeah,
that would be the same.
that's a good point. That would be cool.
And if you did that like daily, several days, because that should be 23 hours, 56 minutes, and 4 seconds, or very, very close to that. And so if you did that like on one day, the star occludes, boom. Next day, 23 hours, 56 minutes, 4 seconds later, the next day, and then you time it then, and then another 23 hours, 56 minutes, and 4 seconds, etc. And if you did that like 3-4 days in a row, you then would know that you're getting a consistent sidereal timing, which then even more so indicates that that star has not shifted out of position. But then even
Quick
to add to
question.
that, you take an image of, or take a shot of the star when it's at your zenith, and then compare that to even add. Then you get the whole 90 degrees to show that it's not changing position or moving in any way out of that cyclical. So yeah.
Okay, quick question. How do you know that it's getting occluded by the tippy top of the mountain and not like on the side a little bit?
Because you're observing it.
Okay,
Presumably, you can see the mountain and
You can see
the
the
silhouette
mountain?
of the mountain. Yeah.
Yeah, dude, have you seen the videos? I'll have a couple
No,
when I
I
get
don't.
home. I'll show you, bro. It's fucking
Okay.
cool.
Yeah, dude, you see it go like, I mean, I guess you do have to make sure you're measuring from the spot that it occluded. Or I mean,
the next day, are
timing.
you going to be able to tell as it shifts over time? There's going to be a period where it's the tippy top, and then the next day it's not going to be the tippy top, or is it always going to be the tippy top?
No, so you're going to move the position. You're going to move your observational position, right?
No, you stay in the same spot.
No, you're in the same spot. You
stay in the same
move
spot. Is it?
Sorry.
Hold on, you stay in the same spot. Is it always going to be the tippy top? That would have to shift over time, right? Because there's
it would be the same.
No, but if you do it 6 months later, though, Gio, you have to be in a different location because the sky and the tilt of the sky, right?
That's what I'm saying.
Oh yeah, you won't be able to see it 6 months later. Yeah, but
That's
so
even
the
3
next
months
day,
later.
presumably, it's
But
slightly
what about 3
changed,
months?
and that's that 4 minutes that you were mentioning before. I thought that had a lot to do with it.
But here's the
What
thing,
about
Jeremy.
3 months later when you still can't? Hold on. What about 3 months later, 2 months later, 4 months later when you still can't see it? It's always going to be the tippy top.
But Jeremy, you change it exactly, Rick. You get it. You change the star because now that star is not going to be occluded by the peak of the mountain. So you'd have to get another star, which is why there's 39 different observations of different peaks.
So
Because you're doing different stars.
So,
all right, but how long can you hold on, man? Can I just get a couple questions real quick? Rick, real quick. You use it one day and then this shift is happening. So you can only use it one day out of the year or from that one spot?
So basically what Dr. Mike did, right? He just set up his telescope, observed the peak of the mountain, and let it go on a time lapse. Noted down the time when a star was occluded by the peak of the mountain. Went in stellarium to confirm what star was occluded by matching the time. And that's what you do. That's why there's so many different stars.
I know, but if he were to do that the next day, it wouldn't be the tippy top of the mountain from wherever he's viewing. If he just kept the camera
right,
there,
which is why he did different stars, right?
That's why there's so many different
So
stars.
how did he know? Hold on, Rick. Let me get a couple questions out. So how did he know? How did he know that was the day for that star? Why didn't he do it the day before or the day after? He just knew that was the day.
No, dude. He just observed the mountain peak with his telescope and watched stars go behind the peak of the mountain. Every time a star got occluded by the peak of the mountain, he marked down the time. Then he went to stellarium to see what star was occluded by using the same time and using the Lati and Longi of the peak of the mountain, right? Turned off atmospheric refraction, so you can get the true position of the star. And guess what? That's how
Just
he got
hold
the
on,
names
bro.
of
We're
the
not
stars.
even that. Just hold on, man. We're not even that far yet. You're viewing the
I
star.
don't understand how you don't understand it.
You're viewing the star one night, right? And then this precession thing happens throughout the course of the year to where you're not even going to see that star at some point. So he does it one night, and then the next night that star is unusable, or is that still a usable star the next night?
It might still be usable. It might not shift that much within one day.
No, dude,
But,
it's
like,
usable for like upwards of 6 months, but definitely 3 months.
Yeah, if anything, the time
Geo,
will
you're saying
slowly
as
shift.
long as you can see that star for Geo, you're saying as long as you can see that star for, it's going to always get occluded by the tippy top of the mountain.
Well, so the sidereal day never changes. That 23 hours, 56 minutes, 4 seconds, like that's very consistent. All these other things, like the precession of the equinoxes and all that stuff, that all really has to more do with the sun, actually, in relation to the sidereal day, because it's solar day versus the sidereal motion. So yeah, like in relation to its position in that way, it's gonna be consistent. But it's same thing could be said like when I've talked about getting like a snapshot of the sky and then doing angles and then doing GPs and circles of equal altitude and all that stuff. When I've done that, when I've talked about that, that would mean you'd have to get like a snapshot of the sky. And you could work with that obviously for like several months, but because of the seasons and the way that the sun path changes in relation to the stars, those, 6 months later, depending on which stars you're using and where you are actually, because the ones in the north are visible year round. But yeah, so it depends on where you're at actually. But some of the stars are not going to be visible. So yeah, it really like ultimately depends on where your observations are taking place from. So if you're really close to the north, you could do it year round.
I got a question about this. That's too much to ask.
You're super low, whoever that was. If you can speak up.
Sorry. I have a question about what this observation is all about. Are you trying to make a right angle triangle from the observer to the mountain and to the star, and then getting the GP of the star and matching that to a planar surface? I'm just curious.
Yeah, essentially.
No.
Essentially, you're basically doing a calculated angle, right? You're not doing a measurement from the observer to the peak. You're just doing a calculation.
Oh, but you're like making a straight line from the observer to the peak to the star, correct?
I think you might
Right.
actually be double checking that it's a right angle triangle.
Wait, B-Ball, have you not seen this presentation yet?
I mean, I've seen it, but I'm just curious.
All right. Yeah, well, you have seen it then? Because so they just take the distance from the mountain and the altitude of the mountain, and then when there's time the star occludes, then you just calculate a triangle to see if it's going to match. And then you go to the top of the mountain, get your stellarium reading of the actual position of the star, and if those angles match, you've just built a planar geometry.
Like from the top of the mountain or from the observer?
Well, I'll let Beasticles go ahead if you want. If you want to explain it your way, I'm just kind of pitching in, and maybe I'm not doing it in the right order. If you want, or whatever, if you want to pick up, I don't have to go through the whole thing with them. But
here, give me 1 second. Grabbing my tea.
But yeah, you go up to the top. You then go to you do the timing b-ball from the ground, and then you take stellarium up to the position of the mountain peak where the star occluded. You get that angle, not the refractive position, but the real position of it. And if that angle matches what you calculated as the angle at the ground, that's the celestial theodolite in a very quick little elevator pitch nutshell.
Okay, because I want to try this to see if it really matches. I'm just curious.
I mean, that's very brief though, so that's not really giving it justice for me to do it that quickly. But go ahead if you want to go.
Yeah, just real quick, just to simplify it. It's very simple. So wherever you're at, whatever observer location you're at, take any peak or mountain around you. The farther away it is, the better, because it'll show the difference between a globe calculated angle and a plane trigonometrical angle. right? So you're just basically making a prediction, right? Just not doing any measurements yet. You're just making a prediction. For example, Pikes Peak from Mike's house, the calculated angle was 2 degrees 31 arc minutes. So what does he do? He sets up a telescope and is observing the peak of the mountain and is waiting for stars to get occluded by the peak of the mountain. So as soon as a star gets occluded by that mountain, bam, you take a snapshot of that exact same time, right? You take that timing, then you put the observer location at the peak of the mountain with stellarium, and then you take off atmospheric refraction to get the true position of the star. And it matches the plane trigonometry every time.
Okay, so question. So wouldn't that give us the actual height of the star above the ground?
No.
Essentially, you're taking an angle from the ground, to the star, and then right to the mountain also. And wouldn't that on the opposite side? Wouldn't that give us the height of the star?
I mean, you could have the maximum altitude for the graticule in terms of altitude height of the star is 6210, but it's all an assumption.
I know,
that's
but
not really the point.
If we're making a right triangle, then it would give us the height of the star, correct?
I mean, you could if you really want to do that. This is what Jeremy asked before, but that's not the point.
But if we're saying it's matching plane geometry, then it would have to, right?
Yeah, the point is it's confirming the baseline part of the triangle being flat, meaning Earth is flat.
Right, so it would give us the height of the star above flat Earth if we're using a right triangle. Can we do this with the sun also?
That's not the point, dude. It's not the point. You're trying to misrepresent the point of this. The point of this is to show the difference between the globe calculated angle, which would have the mountain peak lower than the occlusion time, and in observable reality, that timing is confirmed, right? You are actually watching the star get occluded by the mountain peak. So there's one prediction with plane trig, and then another with globe. And with the globe, because the distance is so far away, the globe would have to have the mountain peak tilting away from you because you think you're on a ball. But then the timing would not match. You understand?
Right. So essentially, the distance from the observer to the GP of the star, right? That's the baseline of the triangle. And the other part of the
No. They're not using the GP of the star in this. No, they're not. Sorry, I have to just interrupt real quick. They're not. No, it's not the GP of the star.
I thought it was a right triangle we were trying to make.
No, the only right triangle, I guess, would just be from the observer on the ground to the base of the mountain to the top of the mountain. I mean, the star is an observation connected to the sky, which I guess you could draw a line out in space or whatever you want to the star. And then, yes, there would be the GP of that star at that time. So you could add a GP thing, but in terms of like what they call in terms of the celestial theodolite kind of presentation part of it, just steel manning that side, like, I mean, Be-A-Stick-Lez, correct me if I'm wrong, but yeah, the GP of the star is not part of it. But you could, in theory, that star would have a GP, and we could. But that's kind of like a separate thing.
Okay, I think that could tell you essentially the. Are we trying to find out the height of the mountain to see if that matches the planar surface?
No.
It's
we're just
the timing.
trying to. Yeah, we're just seeing the timing of when the star gets occluded by the mountain peak.
Which
and that
geometry
way,
it matches.
Right, and that way you take out the refraction argument, not taking out refraction, you're just taking out the argument between you and the mountain peak. Because you're looking at a physical mountain peak occluding a star, right? The light is no longer hitting the observer. Boom. Put that timing down, and then to confirm that timing, right, you go into stellarium, put your observer at the latitude and longitude of the peak of the mountain. And when you take off atmospheric refraction to that same star that was just occluded, the elevation angle matches plane trig every time. GG.
I'm still trying to figure out exactly what you're confirming, though.
You might need to see a presentation about it, or I have a picture for you.
Because why wouldn't the elevation angle match for the star? I'm just curious. I mean, I get the refraction part, but of course it's going to match in stellarium.
Well, if it matches in stellarium, then you're basically confirming that there is flat elevation angles to the stars in order to create the graticule in the first place. That's my interpretation of it.
I mean, we also, if we're going to use stellarium, because I've also heard a lot of, flat earthers not believe in stellarium, because, if you follow the sun, it kind of appears below you at midnight, so.
No,
I mean,
I
you're
mean,
just
Shane's
changing.
That's only if you
yes.
have
Yeah,
the
that's
equatorial grid. That's only if you have the feature called equatorial grid. If you have the one called azimuthal grid, it does not show them going under your feet. And those are the two, basically the models being discussed. I mean, a planar, because they have to have the planar azimuthal because that's the original. It's the OG. It's from the dawn of time, and it has worked since the dawn of time. That's why it has to be in there. So yeah, but B-ball, if you put on the azimuthal one, it shows what we actually observe, which is just what we observe with nothing going below our feet. With like an azimuth plane and the foundation. And then you can flip on the equatorial grid. It then assumes Earth is sphere and then assumes wrapped stars and everything going beneath you.
all right. How do
Yeah, I
I
mean,
get
like,
access?
where did you get that from, Bebop? Like, who said that? Because Shane's entire model is built off Stellarium.
Because all you got to do is pull stellarium out in midnight and find the sun.
No, who said that?
Who said what?
You said that there's like people saying that Stellarium is not accurate or something like that. Like flat earthers say that.
I don't know. I heard someone say that earlier. That it's I'm not sure who it was, but I heard someone say that in here earlier.
Oh.
You're just like swinging for
Well,
the fences, bro.
if stellarium showing
I
the sun beneath your feet, I would say it's not accurate.
okay.
It's
So there you
not when
go.
it's an equator like what Geo just described. You know what I mean? Like, or if you model it the way Shane did, whatever.
All right. Well, I gotta go. I'm going to get food.
So what does Stellarium say is the true angle of the star at the observer?
Say it again. Your mic cut out a little.
What does Stellarium say is the true angle of the star without refraction at the observer?
For which one?
For Pikes Peak, for the celestial theodolite.
I think Beasticles knows that, right? Yeah, Beasticles, do you know the answer to that one?
I don't really understand your question. Hold on, let me switch to my computer.
Well, if I remember correctly, it's like 2 degrees and 5, right? Instead of
He's saying,
2.
what does Stellarium show? Sorry, he's saying, what does Stellarium show for the actual position of the star at the observer's location at the time the star is occluding, in addition to from the top of the mountain?
With refraction on or off?
Off.
With refraction off, it says 204. With it on, it's 219.
204. Okay. So do we trust that figure?
It's not about trusting that figure. That figure doesn't matter. We're not talking about that figure. We're talking about.
I don't care what matters. I'm asking.
We're talking about. We're talking about. Hey. We're talking about when the star gets physically occluded.
I know
by the mountain
that.
peak. Okay.
Earth is Life made a claim that some people in here don't trust Stellarium.
And no one's saying that.
Okay, then why won't you answer the question? Do we trust that figure, yes or no?
That figure does not matter. That's not the point.
If we're talking, the point is, do we trust Stellarium?
Okay, if it says 204, how do I know that the star is actually there? I can't see it, dude. It's behind the mountain peak.
It was just.
That's why that doesn't matter.
What does it say? What does it say? Like 2 seconds before that? Does it say 231 and it suddenly jumps to 204 when you can't see it anymore?
No, dude. When you're at the original observer location, Mike's house, he's looking at the mountain peak.
Yep.
Okay. He's just waiting for a star to get occluded by said mountain peak.
I know.
All right. Boom. That snapshot in time. right when that happens, okay?
Mhm.
In stellarium, it says the star is 204.
Right.
With refraction, it's 219.
Yeah.
But then you go to the mountain peak itself at that
Mhm.
exact same time, take off atmospheric refraction, you get 231. With atmospheric refraction, you get 247.
Right. Did anyone go to the mountain peak physically?
Well, then they're just all off, even on their model. That's just a mess.
Isn't that
'Cause shouldn't
crazy? Yeah.
Yeah. Did somebody
Jeez.
physically go to the mountain peak?
No.
That would be the next. I've thought that too. I think I've mentioned that a few times. Yeah, that would obviously be great to be able to do potentially.
I'm going
Sure,
to
that would certainly be
Pikes
better.
Peak.
But until then, we're trusting Stellarium, right?
Well, do you not trust stellarium?
I'm asking if you trust
No,
Stellarium.
no, no, no. Do
Earth is
you
light.
trust stellarium? You already asked me. I said yes.
I trust
Yeah,
it just
yeah. You
fine.
came in here with the argument that there's people in here that say they don't trust Stellarium,
That
right?
was
And
Earth
now
is
you're
light that came
asking
in here
if
with
you
that.
do, right?
Do you trust
Earth is
stellarium
light.
manufactorum?
I do. Manufactotum.
Okay.
Earth
All
is
right.
Light was claiming that there's some people in here that don't trust Stellarium, and now
That's great. No one's
everybody's
in
running
here.
away from the question.
No one's
What?
in
I don't
here
think
Wait,
we're
running
talking
no.
away
about
from the question,
trusting
bro.
it. I mean, just whether Solarium's accurate or not is what you mean to be saying. I don't think we're talking about like emotional trust and things. I think we're just talking about
I think we all know
You
what
know.
we mean by we trust Stellarium.
It's hard to talk to
Accurate.
this guy because he just wants to straw man the argument and obfuscate. Like I don't get it,
The
dude.
argument was
Well,
about
he
whether
switched
people
his
trust
argument
Stellarium.
completely.
Well,
You
hold on.
switched your
Let's
argument
just maybe
completely.
move out of the. I don't know. Okay, you guys go where you want, but I mean,
I don't
manufactorum.
want.
Maybe like
I just want
what
to
is-
answer his question. He's just like, okay, I answered your
Everyone got
question.
up in arms when Earth is Life said people in here don't trust Stellarium. Everyone was
Okay,
No
up
one's-
in arms.
okay,
that's
did
no
anyone
one
not
here.
say
No
that?
one
Now
said
people are
that.
running away from that.
Oh,
Name
so
one
he
person that
threw
said that.
He threw a straw man in the mix, and now you're picking up on the straw man that no one
Yeah.
even made originally.
What this is
Okay,
recorded, right?
Name the person that said they don't trust Stellarium in this room right now.
I wasn't looking at my screen at the time.
Okay, did anyone say that?
No.
This is recorded, right?
Of course.
Yes, this is recorded.
Can you link me
I
the
think what
stream?
I heard
I'll
was
just find it
there was
right now.
one thing I heard was Jeremy said if Stellarium shows the sun below your feet, I don't trust that.
Yeah, he did say that before that.
Okay, is this your gotcha?
No, it's not a
Ooh,
gotcha. I'm
gotcha.
just asking a question because everyone was all adamant about
Okay,
no.
no
of
one
course
who's
we trust
talking to you
Stellarium.
distrusts Stellarium. All right.
For
You want to
fuck's sake,
continue with the
why-
conversation?
I mean, I'm just so curious why this reaction to that simple question.
Because
Well, I
it's
think it can be
annoying.
accurate, right? I think Stellarium can be accurate, but everything when you're taking angles or distances, you're not going to have absolute truth, right? You have to agree with that because when you come to angles and measurements and whatnot, it's impossible to get 100% accuracy.
Sure, I can agree with that.
Okay, yeah. So then everyone, yeah, I don't think anyone would disagree with that.
Yeah, but I mean, globes do like bend away and have tilt to them, and like things are going to be lower in their position. So that is a very real physical thing that is a requirement for a globe Earth.
Or a globe, right?
So yeah, that's why. Like, I mean, I do agree. Like being able to get to the top of that mountain and do additional observations, I think would be useful. However, you're then going to be maybe dealt with people claiming other kinds of refraction. You know, if people start taking angles to stars with theodolites from up there. So there's going to be then arguments from that as well.
They just want to bring it back in because they hide the globe in refraction, literally.
Oh,
Like,
dude, what if you also like, oh, I was just thinking, dude, like you could track that same star when it rises and when it sets. Like when it rises and then like every day exact like the rise and set points of the star, like the two occlusion points, and then time that. And that would also help validate that it's not bending or warping out of position.
That would be sick. You're saying like if you're in a valley at the certain latitude that a star would rise and set within the nighttime sky.
Exactly.
Yeah, that'd be
Yeah.
sick.
Yep. It just kind of goes to what I was saying before, that if you time the occlusion every day, like every 23 hours and 56 minutes, and you're measuring the sidereal day in the same way, it can't be in some other warped apparent position if it's where it is right at the moment it's setting in terms of its actual cyclical position in the 23 hours 56 minute sidereal motion.
Yeah, what the globe needs to do, anyone who's a globe proponent needs to actually replicate this and show that the timing matches the globe. That's what you guys need to do. So far, no one's been able to do it.
The timing does match the globe.
Really? How? Could you show that?
How does it not? What do you mean?
What do you mean? What do you mean?
What
It
time
doesn't.
is it seen occluding?
Wait, are you saying there was no refraction that day?
That's
That
not
he
what I'm
took the.
saying. What time was it
Oh,
seen occluding?
Listen, dude. The angle is 231. Right? That's the true position of the star from the mountain peak to the
From the
star.
mountain peak, sure.
Yeah. Okay. So you tell me how that matches the globe when it's 219 for the globe.
You said the timing. The timing should match the globe.
Yeah. I'm
Right.
talking about the same timing.
Mm-hmm. And what was the angle at the observer?
You know the angle from the observer. 2 degrees, 31 arc minutes.
That's not my information. Wasn't it 219?
219 with the theodolite. So he took a theodolite measurement to the mountain peak, got 219.
Right.
You could say 217 and then 219 with terrestrial refraction. Great.
Sure.
Then
And at that timing, you should see the star occlude. At the time where it's
the star would be 204 at that time.
the
You tell me.
actual position, sure.
Okay. How does that make sense to you?
I think you know what I'm gonna say.
No, seriously, how does that make sense to you?
So if
That
the
would
actual
mean
position
that
is
would mean they would have to
204,
curve
mhm,
in two different types of like you would have to curve twice.
what are the two different curves exactly?
Okay, if it's 2 degrees and 4 arc minutes, all right?
Mhm.
Just think about that position of the star. Now compare that to 2 degrees 31 arc minutes. Okay, that's 27 arc minute difference.
Mhm.
That's the difference between flat and globe.
Right.
There's no way it's the same. Only one of them matches actual reality.
Well, 218 is a refracted number, right? The
219,
actual
but
number is
yeah.
20. Yeah.
Do you understand? Like if it's
I do
204, the
understand.
actual position of the star, right?
Mhm.
Is
It
this
would
the
be
one you guys
below
are
the
talking
mountain
about?
map. Yeah.
Is this the one
Yeah.
you guys?
So if the actual star is at 230, 231, well, how tall is the mountain? Then the mountain should also be 231, right?
What are you talking about?
So the actual position of the star is 231,
Uh-huh.
right? And we're talking about the timing when we observe it occlude by the mountain.
Okay.
So that should be 231, you're saying,
Yeah.
at the observer
That's what it says in Stellarium.
to the mountain. It says at the observer it's 231?
No. It says from the mountain peak to the star.
Right. So we've tossed out stellarium for the observer. That's fine. So at the observer, we should see the mountaintop. The true position of the mountaintop should be 231, right? From the observer.
I don't know what you're saying now, dude. You're going all over the place.
The angular height of the mountain from the observer should be 231 if these 3 points line up on a flat earth.
Yes.
Okay. Is the mountain at 231?
Using the star to confirm it, yes.
So that's circular then.
What do you mean it's circular?
We're now back to the star to confirm the angle of the observer.
That's the point of using the star getting occluded by the mountain peak, bro. That's the whole entire point.
But the timing was the basis for that, the time we take that angle.
What are you dude? It's very
We're
simple.
getting the angle from the top of the
Very-
mountain at
It's very
the
it's
point where it
very
gets
simple.
occluded by the observer. Please do not repeat it to me. I've understood the experiment.
Okay, well, it seems like you don't
You're getting-
understand it.
No. You're not understanding why I'm saying it's circular. I'm trying to explain.
Okay, maybe steel man it. Maybe that'll help. Maybe just to
No,
clear it up.
The level of price, we've heard it a million times.
Okay, then steel man it.
We're getting
Verify
the
first.
timing. Oh my God. We're using the timing to get the angle of the star, correct? That's a yes.
No, you're just
No.
getting the timing to get the like more like a straight line.
Yeah, so maybe you do need to steel man it.
It's like a straight line observation, like a straight line observation point to the mountain peak.
Tora posted a nice little picture there.
We're
You see that?
I got that from you, brother.
I see the picture. Yes, I see the picture.
Okay.
How are we getting the angle to the star?
With stellarium and using the timing that was
There we
observed
go.
in reality.
Thank you. We're using the timing to get the angle to the star. That's what I said the first time. But the timing requires the observer to observe the star getting occluded.
Yep.
Right? So
Yeah.
so if we know the angle to the mountaintop, right? That would give us the angle to the star. That would give us the same line, the lineup of the star, the mountaintop, and the person.
Check it out, bro. Even if you didn't measure the angle from the observer to the mountain peak, the calculation, right? The plane trig predicted angle is all you need. That's it.
But that's a calculation, right?
Yeah, it's a calculation, and then it's confirmed with the timing of when the star gets occluded by the mountain peak using stellarium.
I think he just became a flat earther because he just used a flat earther rebuttal.
The timing requires an observation. And you're
Yeah,
saying
wait.
Yeah.
What do you mean the timing required? Yeah, of course. That's
Okay.
how he got the time in the first place.
Right. So all we would
Okay.
need really to confirm that any of this is true is to measure the angle that the observer sees the mountain peak, right?
Repeat that.
So in order to confirm this, that these three objects line up, the observer, the mountain peak, and the star, is to simply, now that we have that calculation, we simply go to where the observer was and we measure the height to the mountain peak, the angular height.
No.
Why
Dude,
not?
it's confirmed with the star being occluded by the mountain peak. That's what's confirming it.
Okay, do you expect we would get a different answer?
What he already did a theodolite measurement to the height of the mountain, and it got
And that was?
219.
Right. Why?
Well, that's because of the theodolite, bro.
That's because of the theodolite?
That's because of the theodolite. Yes.
The theodolite was misreading the height of the mountain?
So in his PDF, he shows a scaling error, which is why when you use theodolite, you're only supposed to use it respectively from 100 meters to 200 meters from A to B to C. That's the point. You have to actually confirm that straight line. When you're 50.7 kilometers away from the mountain peak, then you're dealing with a whole bunch of optical phenomena in between you and the mountain peak. This is the reason why he came up with the concept in the first place, because he heard about all of the arguments with refraction. So he wanted to get rid of that argument by using the star getting occluded by a mountain peak. That way, you can literally take away all of the refractive index, like all that refraction between you and the mountain peak. Now that's not a factor anymore because you're using the actual timing of when a star gets occluded by the mountain peak. You take that out of the equation. That's the point of this entire experiment.
Yeah. So you're saying that the light from the star and the peak refracts from the mountain peak to the observer.
No one's saying that. You are saying that.
Well, you'd have to say that.
No, I don't. You have to say that to
There's no
save your globe,
refraction
but
between the mountain
it's
peak and
impossible.
No, sorry, you're saying there's no refraction from the mountain peak to the observer?
We're not saying that. We're not. That's not part of the equation.
But it's part of
Because
the observation.
no,
How is the
dude.
mountain at 219 at the time that
Because
it's
the star
231?
gets occluded by the mountain peak. You're looking at the
Right.
mountain peak. You're seeing the star go behind the mountain peak.
You're seeing
That's
all of
it,
that at
bro.
219.
It doesn't matter about the refractive index
You
between
don't
you and the
want
mountain
it to
peak.
matter, but it's in
No,
there.
it doesn't matter. It literally doesn't matter. That's the point of the celestial theodolite, bro.
Okay, let's agree that it doesn't matter. I'm gonna just humor me. I'm asking anyway. If the mountain peak and the star at 219, but the true position is 231, there's refraction happening, right?
What are you talking about?
The true position of the star is at 231. This should be true for the mountain
At
peak
that
and for the
time,
observer.
from the mountain peak.
Right.
Okay.
So if he observed the mountain peak at 219, there's refraction there.
Well, if you want to incorporate refraction, you know what happens to the star?
The
It
same
also
thing
gets
that
refracted up to 246, which means it wouldn't have been occluded. GG.
That's not true at all.
That's exactly true. That's the point of this.
No, look at the thing before. The one above what Tora posted, the one Geo posted. See, it says 246 and 219.
Yeah.
Yeah, because those angles are taken from two different verticals. That would make perfect sense.
I don't know how that would make perfect sense to you. You'd have to use two different refraction calculations between you and the mountain peak and then the star and the mountain peak. But it's the same observation. It's one optical corridor.
Yeah, but it's not the same triangle like it would
It
be.
is. It's the same. It's one observation, bro.
It's one observation.
It's literally the same time.
I understand.
You're not. How are you using two different refractive coefficients between you and the mountain peak and then you and the star? You'd have to.
No.
In order to get the timing to match, you'd have to.
No, I think you misunderstand the globe claim. The mountain is at a different vertical than the observer. That's going to give you two different angles.
I don't get what you're saying.
See how the mountain is tilted?
Yeah.
Right. So
which
if you
means the
draw a line
timing
from
would
the
be
top of the
different.
mountain- No, doesn't mean the
Yes.
timing would be different. If this is at this image, their atmosphere on globe Earth, that's at the same moment. That's one moment in time, the same time, presumably, that the other alleged observation was done. They're two different verticals, right? Converging verticals. So you would expect there to be two different angles at two different locations.
Hey, I've got a question really quick. So after the star gets occluded by the mountain, do you think we could still use stellarium to track the star for another few hours?
What's the point of doing that?
No, sir. I do not think that you can do that.
But wait, what's the point of doing that?
I was just curious.
What I don't get. Why are you asking that question? That doesn't make sense to me.
Well, he thinks it's a gotcha. He thinks that it can help prove his model.
How? The only thing that matters is the timing in real life. When you actually observe a star get occluded by the mountain peak, that's the only timing that matters.
Okay, so what happens to the star after it gets occluded? Which direction does it travel?
What?
Does it continue?
It would continue to go below the mountain.
Could you continue to track it?
What? It doesn't matter.
I'm asking, do you think we could still use stellarium to track the star?
You can use stellarium to do whatever you want, yes.
Okay, so what happens when the star appears like below me at midnight?
Oh my god, you're going to this argument again.
I'm just curious, man. I mean, if we're using stellarium to track stars, why can't we do that?
B-ball. Okay, so if the mountain wasn't there you would be able to see the star for a little bit more. But if you've ever been on like the ocean, the star will eventually set. So
That's correct. But could we continue using stellarium after that to track the star?
I'm just saying the difference of
answer
the
is questionable.
mountain being there or the mountain not being there is only a little bit. So just because it's going to go further, it would go like more down if the mountain wasn't there. That doesn't mean it's going down below your feet or wrapping around a sphere.
I mean, where is it going? If we're using stellarium to track the star until it gets occluded by the mountain, why can't we continue to track it with stellarium?
You can do whatever you want, bro. Whatever tickles your fancy afterwards. That's not the point. That's not the point of the celestial theodolite, bro.
Well, what are the implications of us being able to track it and see it like literally go below us? Like, is it no longer accurate after that?
The azimuthal grid is accurate. The equatorial grid is not accurate. One has to be accurate, one has not to be. It has them both.
Crazy
the azimuthal is the correct one.
I like how he doesn't want to address the celestial theodolite. He just wants to change it to a different argument. It's so annoying.
Yeah, that's weak. Yeah. Do you have any actual anything to actually rebut to the? We can go. I mean, B-ball. That's kind of a separate topic. I mean, is that really what you wanted to do?
But why is that not a thing, though? I mean, if we're using stellarium, we should be able to continue to track the star.
See, he's just
why is it different? Why is it different once it goes? Why is it different once it goes below the horizon?
No one cares, bro. We're not even talking about that. We're talking about the celestial theodolite observation. Do you want to bring a rebuttal to that, or have a question about that?
Isn't that a question? Don't you question that though? Why wouldn't you question that?
Question what, dude?
Why you can still track the star after it goes below the horizon? Don't you wonder about that? Like, is the star still there? Is it still going in the same path?
Okay, so you do know that stellarium was created with the nautical almanac, right? You do know that?
Right. Yes.
Okay, and how was the nautical almanac created?
By observations?
Yeah, by using flat baseline elevation angles to stars.
But apparently stellarium doesn't do that. So does that mean stellarium is incorrect once it goes below the horizon?
No one's saying stellarium doesn't do that, dude. It's just a negative coordinate system. All right, it's not a big deal. It's just out of our field of view. So what? Then it becomes a negative coordinate.
Where does it go once it goes out of our field? Does it make a right
It goes
turn?
away. It goes out of your field of view.
Where does it go?
Away from your field of view, bro. From your radius of vision. That's it. And then it's measured by a negative coordinate system, right? You can transpose that coordinate system into any way you want. It's just a spherical coordinate system. That's all it is. It's just a mathematical construct.
Okay. Let's say the Earth was a globe, right? Do you think we would be able to track it all the way until it rises the next night or the next morning or whatever?
Yeah, obviously. Yeah.
Let's try that. That should be a thing we should try.
All right, bro. I'm done with this. This guy's nuts.
So the nautical almanac was always made with like globe math, by the way.
Oh yeah?
Yeah.
How?
Calculations?
Show me how, bro.
What do you mean?
Because really,
you want me to make one?
Show me the globe math that was used to create the nautical almanac. Right now.
Within 10 seconds, or we're dropping you into a pit of snakes.
Exactly.
So the nautical almanac, as far as I understand it, deals with positions of the stars and their movements. And their movements are based on, if I'm not mistaken, the line of Aries. It's been a while since I've done this now. The line of Aries has to do with the rotation of Earth. Allegedly. We can say either one is rotating the Earth or the sky, but it's with rotation around a globe. It's using the two poles as the sort of axis of rotation, a single axis of rotation for a sphere.
Wait, that's where you went with that? Assuming motion from something separate from it?
No, we can assume that the Earth is stationary, the sky is moving, but it's still a spherical sky moving around a spherical Earth.
Did you say from something separate from it?
No, a globe. It's using the two poles as the sort of axis of rotation, a single axis of rotation for a sphere.
Wait, that's where you went with that? Assuming motion from something separate from it?
No, we can assume that the Earth is stationary, the sky is moving, but it's still a spherical sky moving around a spherical Earth.
Did you say from the 0 Aries point?
I believe that's what it's called.
You mean 0 degrees, 0 minutes, 0 seconds of Aries? Is that what you're talking about?
No, it's the first when something rises on the equinox or something. I gotta look through my notes. I don't remember exactly. Let's see if I can find it.
The sun on the equator at the equinox?
Maybe.
Wait, but what was your point of how that linked into it?
Greenwich hour angle. That's the one. Line of Aries. Yeah. A reference point used to measure celestial position.
Okay. What does that have to do with the shape of the ground?
It's exactly what I said. Yeah, 0 degrees, 0 minutes, 0 seconds of Aries. Yeah.
Yeah, that.
Yeah, what does that have to do with the shape of the ground, bro?
It's the two poles around which all the stars move and how they move around those poles. So the timing is going to be as you would expect from a sphere around a sphere, nested spheres, so to speak, around those poles. So the timing is going to be as you would expect from a sphere around a sphere, nested spheres, so to speak, around those poles. So the timing is going to be as you would expect from a sphere around a sphere, nested spheres, so to speak.
Are you talking about the precession of the equinoxes?
No,
I really don't know what he's talking about.
nothing on that.
Yeah, I'm trying to say it. Maybe I don't know. Start over, maybe, or
I mean,
just say it again, maybe.
Basically, the claim was that the nautical almanac was made from like angle measurements from the ground.
Oh, right. Let's start over from there. And you're saying it's all globe stuff. Yeah. Could you maybe do we just make like a good solid like elevator pitch case, like concise at all, so then we could get it? Thank you.
I can try. That's kind of true. Like, yes, that's where you start from, but those have to be put in a globe context or they just don't make sense. I guess that's the long and short of it. I mean, it's basically the old argument of the sky only makes sense on a globe. That's basically it.
Nah, dude, that's just your conception, bro. You think spherical coordinate system? I must be on a spherical ball.
Mm-hmm.
Yeah, I'm not going to make that logical leap.
Sure. I mean, it seems like most flat earthers agree with that, which is why they tend to throw out the sky.
Wait, but do you have evidence of wait,
well, the first almanac was done after.
Yeah, do you have any that's what I was going to say. Do you have any evidence of that they used the globe to build the almanac? Cuz that was
No, his argument is it looks
that was
that
kind of
way.
the point you guys were on. That was like the point. It was like
Pretty
right
sure
at that.
the almanac comes from Babylonia, or Babylonian text, like the first almanac.
About the nautical almanac.
Right, but I'm just saying an almanac basically originates from Babylon, and that was way before the globe model was ever conceived.
Like
it's
idea
literally
of an
just
almanac?
What?
The idea of an
Is the
almanac?
argument because
Yeah.
you see something, you believe another thing? Like you see stars moving in a certain way, so then you make a belief off that? Like
That's
you're
Exactly what
making
they did.
measurements, or you just see it? Like
right
you're
on.
like, I just see it. Because like, wouldn't that just apply to the horizon? Like, then wouldn't you accept the argument like the horizon looks flat, therefore it is? Because that's your argument right now.
That's absolutely the argument. Right on top of things. Well done.
Yeah, definitely.
So the
I'm just
first
saying.
nautical almanac I'm
Oh,
aware
sorry,
of
go ahead.
was after they were well aware of it being a globe, or after they were well presuming it was a globe, if you like.
It sounds exciting, guys.
I don't know, dude. I kind of don't want to play fuck around with this guy.
Yeah, it kind
Maybe
of
I
sounds like
missed it.
67.
presuming. What even
Number
is an almanac, sir? Can you explain that?
what?
Can you define what an almanac is? What is that?
The nautical almanac. It's a list of stars and their positions at specific time.
Okay, so is that different on a flat Earth versus a globe?
Kind
Nope.
of.
Nope.
Well, if
Can
we're
you give
talking
the argument for why it's kind of?
sure. So I think what was it Life is Earth who's in here earlier was getting at the first time was if we use trig to calculate the heights of stars from the positions from which they're viewed, you can't do that assuming plane geometry. And you can't do that and get rational answers, rather. Good. Glad you're coming with me on that.
Is there a topic or what's going on here? Is there something happening?
I don't know.
I think we're kind of just lost in translation here.